Open loop testing lets us measure a device when it's not possible to play the stimulus and record the response from soundcheck at exactly the same time. For example, smart devices, phones, and more. This is simple in soundcheck since its architecture has always allowed analysis to be performed independent of acquisition. In fact, we pioneered open loop testing, originally for MP3 players, back in 2006, a good 10 to 15 years before others started implementing this capability. Let's start by explaining how open loop testing is different from conventional closed loop tests. In conventional audio tests, such as speaker and microphone tests, the stimulus playback and response recording occur simultaneously. The two signals are correlated and ready to analyze. Devices such as mobile phones and smart speakers do not have a simultaneous input-output audio path, but we can test both the speakers and the microphone using open loop testing. In open loop testing, the stimulus includes a trigger to tell soundcheck when to start recording. Let's look at a mobile phone test. For the speaker, a stimulus file is loaded onto the phone and played back either manually or via a command. Soundcheck records the response using a trigger record acquisition. To test the microphone, a stimulus is played through a mouth simulator and manually or via a command recorded to the phone. The recording is then transferred to soundcheck for analysis. I've already uploaded the stimulus file onto my phone, and I'll manually play back the stimulus file and trigger the record in soundcheck. This short sine chirp in the stimulus file serves as a trigger and is not analyzed. This is a sophisticated level and cross-correlation trigger that is more robust and less susceptible to false triggers than simple level and frequency options. The test sequence then uses resampling and frequency shift post-processing steps in the sequence to correct for sample rate mismatches and slight sample clock differences between the device under test and your interface. This enables perfect alignment of stimulus and response for accurate analysis. I'll run the sequence. There you go. The top graph displays the frequency response of the phone's speaker. To the right is the recorded response superimposed over the stimulus. The bottom graphs include THD, rub and buzz, and enhanced rub and buzz. Let's look at some other examples. These Apple Lightning wired earbuds can't be tested using the standard headphone test interface, as these do not support the proprietary connector. However, the Lightning earbuds can be connected to an iPhone, and the phone can play back the test stimulus. Open loop testing even allows testing via the cloud. With a smart speaker, the stimulus file can be uploaded to the cloud and accessed and played back from the cloud via voice command through the speaker using the same triggered record acquisition that I demonstrated earlier. These are just a few common examples, but with these methods, you can measure just about any device or system that does not have a direct wired connection between the signal input and output. Check out our seminar on smart device testing for more open loop demos.